Well, hello, everybody. My name is Makala Smith. I am a part of the Alabama Plasma Internship Program. I will be talking about fiberized industrial hemp seed. Previously, my partner Alex, she talks about feminized industrial hemp seed. Um, my host institution is Alabama A&M with my mentor Ernie Siebert. So first, we're going to start off a little bit about me. You know my name already, Makala Smith. I'm from Detroit, Michigan. I have a bachelor's in science, and this is my second year in plasma research. So before we jump right into the presentation, we're going to talk a little bit about the outline and how it's going to be. First, I want to talk about plasma and how it's applied to agriculture. And then we're gonna dive into a background of hemp and talk about the trials and experience that we did with this experiment. First, let's talk about a little bit with general information on plasma. Plasma is generated by passing electricity through noble gas such as helium or argon. An example of plasma that you may already know is with space weather. Different types of plasmas could include plasma in corona jets and also microwavable plasma. With plasma comes low temperature plasma. So even though they're pretty much the same, there are quite amount of differences. Temperature plasma consists of neutral particles, ions, and electrons characterized by a collective behavior. Unlike plasma, low temperature plasma can be touched in some parts, but can still be dangerous. Plasma can be generated in different instruments, such as a sheet, jet, or a chamber. So with low temperature plasma, we had the experience of dealing with it with UAH and UAB. At UAH, they had built their own plasma, and they use a jet and a sheet with helium at 8.17 kilovolts at 10.2 milliamps. At UAB, the chamber was purchased. It deals with nitrogen at 0.988 torr. So that's just a little background about the difference between the way plasma can be used with UAH and UAB. So, low temperature plasma in agriculture. LTP have always been shown to increase the rate and total seed germination. It has been shown to improve plant growth and yield, and it also has been shown to reduce seed-borne diseases while also disinfecting fresh vegetables and meat. Plasma can also be used indirectly with plasma activated water. It is a sustainable agricultural production with food processing, decontamination, and food safety, and also food preservation. And that picture right there just shows the difference between plasma activated water and non-plasma activated water. So now we're going to talk about a little bit about hemp and the history and uses of it. Hemp was brought to North America at around 1606 in the 1600s. It was mainly used for fiber in the European settlements in Canada and the United States. But in the 1970s, hemp was classified as a Schedule I drug by the USA Controlled Substance Act. It became illegal, but in 2014, with Section 7606 of the U.S. Agriculture Act, you are allowed to work with hemp as long as you get permission. for the program that you're doing from the state. Some uses of hemp include fiber, oilseed, or pharmaceuticals. Um, some examples of this could be hemp building materials such as hempcrete, hemp pulp, and other things such as hemp yarn and things of that nature. A lot of people use hemp for CBD purposes as well, and the oil seed or for pharmaceutical use. And this is an example of hempcrete right at the top right corner, and the hemp fibers as well. So within hemp, it is still cannabis. So with hemp, there comes THC and CBD. Um, THC is that main psychoactive compound that produces the high sensation, while CBD does not contain that at all, but has the medical benefits. CBD also include other cannabinoids that has the healing properties for the medical benefits, but it does, as I said, it does not include that high sensation that THC will give. For the hemp that we used, it had to contain less than 0.3% THC. So after anything above 0.3%, it was considered illegal in the state of Alabama, and it will be considered as marijuana. So we didn't want that. So this is, I will be talking about trial 1 of the experiment. Before we could do anything, we had to prep the seeds. We used 4 varieties of hemp. From those 4 varieties, we had 50 seeds from each variety, totaling 200 seeds altogether. As I said earlier, Alex and I were working together but separately, as she did with Feminized and as I did with Fiberized. The difference between the two is Feminized were genetically all female, and Fiberized was just a 50-50 mix. We wouldn't really know which is which until pretty much later on in its germination period and as it grows taller. But okay, so 200 seeds altogether from each variety, and the category of seeds was that we tested it under was dry untreated, soaked untreated, and dry and soaked treated. But before we treated the seeds at UAH, we soaked them in deionized water for 24 hours in a petri dish. And that was just all the seeds that you see here listed as for soaked, untreated, and soaked treated. Here is some photos of me and Alex preparing the seeds, and those on the left here are the seeds 24 hours before treatment soaking in our laminar flow hood here at the station. So treating the plasma at UAH, we actually used the sheet plasma. I will show you what that looks like in a second. But we treated the seeds for 60 seconds in a separate petri dish. We treated the soaked seeds and also the dry seeds the same day. Here is that picture that I was showing you earlier. This picture right here in the middle, I don't know if you can see my mouse, is the sheet plasma. They put it on like a copper base, and this little thing right here, I'm not sure what it's called, but basically it just lets off the plasma, and then that's me dealing with it. So after treating the seeds for 60 seconds, we put them in the flow hood for germination. After that, germination rates was recorded over the next week. We had a very strict time schedule of time ratio of leaving them to sun and dark and watering them. Basically, it was an everyday thing of keeping track of how it should look. But the results were that soak treated came to be better than all the others. So we realized that soak treated had the better results versus soaked and dry and untreated. Um, and that was just across the board with this trial. Um, soak treated did significantly better than dry untreated. And here this graph explain that, the Duncan grouping graph. As you can see, this is me and Alex's data combined together. Um, um, this graph just pretty much shows the difference between soaked, dry, treated, and untreated. And as you can see at the top here, that soaked treated is does better significantly than dry treated. With Duncan graphing the, okay, feminized at 5. I also want to mention as well that feminized does better across the board than fiberized did. As we discussed earlier, feminized is all female, while fiberized is all with 50-50 mix. And here are some pictures of the germination phase. This picture here on the left was 2 days after treatment. You can see that we have a little bit of a germination. This is the first measurement that we took. This picture on the right here is the last measurement we took. And this was about at the end of the week, so about 5 days later. And you can see how 5 days can truly make a difference with plasma in the hemp. So after taking our measurements and whatnot, we didn't completely scrap the seeds. We decided to see how they would do planted in a germination tray. So we planted them here at the Shade House at the university's farm. On the left, you see the germination trays clearly labeled and before it germinated more. But on the right, this was a couple of weeks later. This is feminized. Again, as I said earlier, feminized did significantly better than fiberized. You can see that the feminized plants are growing nice and healthy there. But those are just a couple of weeks apart. Okay, for trial 2 of the experiment, we wanted to do something differently. This time we worked with 6 different cultivars, 100 seeds from each cultivar, 300 for me and 300 for my partner, Alex. Again, she worked with feminized, I worked with fiberized. And within that 300, we used 10 seeds for each treatment, and half of those seeds were treated at UAH, while the other half was treated at UAB. With this trial, we wanted to observe the seeds more closely and accurately. It was very hard to differentiate and trial 1 with the different seeds because they were all bundled up in a petri dish. And also we thought it would be good for our data to do it this way as well. Each seed was individually labeled, weighed, and separated. And we also, so instead of exposing the seeds for just 60 seconds as we did in trial 1, we exposed them for 30 to 120 seconds to see what would be the optimal time to treat the seeds with low temperature plasma. And as you can see here in this picture, these are seeds individually wrapped and labeled in each of these tubes here. So trial 2 treatment. Each seed was individually treated so it can maintain its seed number. Again, we did keep the same aspect with having the 4 categories such as dry untreated, dry treated, soaked untreated. So half of those seeds were soaked 24 hours before treating them to the low temperature plasma, but we still maintained the seed number and treating those seeds separately. As you can see here, we used the plasma jet for this trial of the experiment at UAH. Um, right here, it looks really, really cool, by the way. But as you can see, it's individually hit the seed. And then this is another example in a Petri dish of it individually treating the seed. So yeah, I thought that was really cool to see the jet used like that. For the rest of the seeds, the other half of the seeds, they were treated at UAB in the chamber. We put them in a modified tray, so it will be easier to put, easier to keep it all together and labeled and put in at the same time because it was a little bit smaller than what we expected. We had to cut the trays in half and still make sure that our seeds were labeled so that it can maintain, you know, the same number that we gave them to us per prepping the seed. So with germination after treatment at UAB, we measured the seeds over the next week and recorded the data in this spreadsheet. The seeds were placed here in the, as photographed, the germination chamber. Again, we had to closely watch that for any changes or observations that we needed to make. We also had to label, even though in the germination tank, we still had to label and upkeep the seed number so that we know which is which. So with the data that we received from them, this is also mixed data as well. We've noticed again that soaked seeds germinate significantly better than dry seeds. We found that the optimum range of the seed for Fiberized, for my experiment, that it was 90 seconds. So majority of my seeds did its best with 90 seconds of exposure of low temperature plasma. But again, Feminized did better across the board with this trial as well. And I believe for Alex's experiment, I believe 60 seconds was the better optimum range for this trial for her. Okay. So besides treating our seeds at UAB, we also treated, this is a side project, we also treated barley and a mixture of fiberized seeds. They were treated in the chamber for only about 60 seconds. The barley was sent to Harvard College in New York for alpha amylase treatment. The hemp, unfortunately, we didn't have nowhere to send it to, so we had to scrap those for treatment, but it was initially the same thing. So with the hemp, it was the fiberized soaked and the fiberized dry, and then with the barley, it was barley soaked and then barley dry that we all put in the chamber for 60 seconds. And here is a picture of that and how the germination looked afterwards. This on the left is barley after germination, after being treated. And this on the right is the hemp after treatment at the chamber of UAB. And as you can see, there's a lot of growth there. So that was really good to see. So my conclusions of this experiment is we have concluded that soaking seeds before germination of treatment will give you the best results. We also concluded that dry seeds that were treated with plasma also had an increase of germination speed. And with this experiment alone, UAH jet and sheet plasma was better exposure for the hemp seed. The chamber changes, we also noticed that chamber changes certain characteristics of the seed. My partner, Alex, actually pointed out that after exposing the seed to the plasma in the chamber, that it kind of does, like, she likes to call it the turtling effect. The scarification in the seed gets more distinct when using the chamber. And that's the end of my presentation. I would like to give, that's the end. But I would like to give my thanks to this organization, CP2AL. I would like to give thanks to all my mentors, Ernest Siebert, Dr. Manready, and also the extra help that I have received over these last 10 weeks. And that is it, you guys. I hope you guys enjoyed.
Hi, my name is Flasmy, and thank you for watching this video. Make sure to follow us on our social media at CP2AL on Facebook, LinkedIn, and Instagram. Bye!